Eric Burgess here, and we've been asked how many ways can the letters B, 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 A, C, D, E be arranged? So looking at this, it's different than before because we have three B's here. They're all the same. So for example, I could swap this B and this B, and it would look like the exact same thing. It wouldn't be any different. We have to remove the extra bits that repeat. That would cause it to be no different. So for example, how many do we have here? We have 1, 2, 3, 4, 5, 6, 7 things. So we've got 7 things here, and we know that the way to find the order of number of things by the fundamental counting rule is just 7 factorial. But we know this is too big because it includes all of the versions where these 3 B's are switching around. So what we're going to do is we're going to divide them out. By dividing, we remove those extra possibilities. And right now, it's basically, we want to remove these 3 B's. So all the different ways we have to swap these 3 B's need to be removed so that we get only the ones that matter. So here, that would just be 3 factorial. That's how many ways we can swap around the 3 B's. So this would be our answer. And so this would be 7 factorial over 3 factorial. Type that in our calculator here. We'll go, I'm going to put down parentheses, 7, math, probability, the number 4 to get the factorial, divided by parentheses, 3, math, probability. We go down to 4, and we're going to get 840 ways. Now you could alternatively also do 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Simplify out the things that are the same and just multiply these. I know that some professors, that's how they evaluate these things. So there's one other thing I want to point out here. And what if we had instead the letters B, B, A, C, C, C? Well, this is a bit of a different case because we have multiple things that are repeating. So we would need to, in this case, take out all the ways we can swap B's, all the ways we can swap A's, and all the ways we could swap C's with themselves. So we have how many objects here? 1, 2, 3, 4, 5, 6, 7. So we again have 7 objects. But this time on the bottom, there'll be even less unique strings here. There'll be less unique ways to write out these lists of letters, because there's less unique letters. Up here we had more of them. So here we would have to take out, well, there's 2 factorial ways to change out the B's. There's 2 factorial ways to switch around the A's, right? Because there's 2 A's. And the rule for the fundamental accounting rule tells us that we multiply 2 factorial. And then we've got 3 factorial ways we can switch all the C's around. And so this would actually be the expression for all the ways we can switch around this string, which you see we are dividing out much more than we are in this one. So, and that makes sense. It sort of follows logically because there's more things that are getting swapped around here. So that is how you would do a problem like this. If you have any questions, feel free to let me know in the comments below. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.